Howdy y'all, today's lesson is on systems of equations. Specifically today we're going to talk about what a system of equation is and how to solve a system of equation using the graphing method. Okay, so on your notes here I want you guys to go ahead and fill in the blanks. So what is a system of equation? It's where you have two or more linear equations. So for the purpose of this class, we're only going to be dealing with two linear equations. When you move on to some more difficult, higher level math classes, you'll see that sometimes you'll have more than two linear equations. What is a solution to a system of equations? The solution is going to be the point at which two lines intersect. So when you look at your graphs, and you guys are going to be graphing a bunch of things today, when you look at your graphs, if you have something like this in the far left of your screen, this is what we call one solution. Okay, this is going to have one solution because these two lines hit at exactly one point, and that would be your solution, whatever that order pair is. When you have parallel lines, those lines are never going to intersect, so you're going to have no solution there, no solution. And then if you remember the symbol, it looks like that. And then when you end up, let's say you're given an equation in slope-intercept form, and then you're given another equation, remember, because you have to have two or more, the other equation's in standard form. When you convert that equation, it ends up being the exact same thing, so you get the same exact line when you graph them. That's what we call infinite solutions. This is going to be infinite solutions, so we're going to have that symbol right there. Okay, so let's look at number one. A lot of this is going to be review for you, especially if you remember how to graph something that's already in slope-intercept form. So first step, when you're given two or more linear equations, the first thing you want to do is make sure that those two linear equations are in y equals mx plus b form. For number one, if you look at our system here, which we've already got two linear equations, there's our system, they're already in slope-intercept form. So we want to go, you're going to graph this first equation. So here, if we look at your first equation, we've got an m value of 1, and then our y-intercept is going to be -8. So you need to go down to -8, and you plot a point. So go ahead and go down to -8. 1, 2, 3, 4, 5, 6, 7. Plot a point at -8. And then you want to go up 1 over 1, up 1 over 1. I'm going to do my best to make straight lines with this big pen that I have. It's not very easy to write neat, as you guys have probably realized as you watch these videos. So go ahead and connect all those dots. Let's make a line through your graph because you're going to want it to intersect with another line. So go ahead and draw a line through the whole graph there. Then let's plot the second one. So for my second equation, I've got an m value of -2, which means I'm going to go down to right 1, but I've got to start at 1. There's my y-intercept. Plot a point at 1, and then I go down to right 1, down to right 1, down 2, and I'm going to keep going until I hit that point, and that, your lines hopefully are going to be much straighter than mine, but this right here is the only point that I care about. So figure out what that point is. So it looks like it's 1, 2, I've got an x value of 3, and a y value of 1, 2, 3, 5, -5. So my answer to this system of equations is going to be 3, -5. And again, what I'm looking for is where these two lines intersect. So right at that point right there, that's really the only point you care about on the graph. So that's going to have an x value of 3 and a y value of -5. Okay, let's look at number 3. I'm going to jump around. So I wanted to choose one where they're not in slope-intercept form already. So you have to convert those to slope-intercept form, which we know is y equals mx plus b. So for this first one here, this first equation, I'm going to convert that. That's going to be y equals 3x plus 8. So then I need to graph that. And then my second equation, I'll just write it down there, is going to be y equals x minus 2. So I'm going to go ahead and graph those. So for the first one, I go up to 8, and then, ooh, I like those problems because now you'll see I've got one of those special cases where if I go up 3, I'm out of graph. So I have to go down 3 to the left 1. I don't like going to the left, but sometimes we have to. Down 3 to the left 1, down 3 to the left 1. Okay, so plot those points, and you want to make a line through that whole graph. So make a line through that whole graph. Again, I'm doing my best to be neat. It's hard. and good. And you have to be really precise here. You have to be really precise because you need to find the exact point that those two lines will intersect. Let's graph the second one. So I'm down at -2, and then I've got a slope of 1. So up 1, over 1, up 1, over 1. I'm going to make a few points in the opposite direction because obviously that's where my answer is going to lie. And it looks like it's going to be right there. Perfect. I think I found it. Connect all those dots, and then let's figure out, again, the only point you really care about is this one right here where the two lines intersect. Let's figure out what that point is. So my x value is going to be negative, so -1, 2, 3, 4, 5, -5. And then my y value is going to be way down here at -7. So there's a solution to that system of linear equations. Okay, let's do a special case. You're going to see a special case here with this y equals -7. If you remember that, that has a slope of 0, so you're going to find -7 on the y-axis, and you're going to plot a line that goes this way, and slope dude, remember he's having 0 fun when he goes this way. So that's what the 0 slope line looks like. And then if you look at number 8, if you look ahead, that's going to be our other special case. So x equals -2, that's going to be an undefined slope, so it's going to go the other way. Okay, so I've already graphed that. That's good. That one's actually fairly easy if you recognize that that's one of your special cases. Number 5, you got to, number 1 here for number 5, you got to convert to slope-intercept form. So y equals -1/3 x minus 5. I'm skipping some steps. Do not recommend that. So let's go ahead and graph that. So I go down to -5, 1, 2, 3, 4, 5, and then I'm going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. I think I found my point already. So connect those dots, and then let's figure out, the only one you care about is the one right here where those two lines intersect. So we know for sure the y value is going to be -7, right? Because that line is not going anywhere else but there. And then let's figure out what the x value is. So I've got a positive x value, looks like a +6. So there's the solution to my system of linear equations. Okay, so this was a short video. I hope you guys find that most of this is review. All you really need to do here is figure out where the two lines intersect. Hopefully you remember how to graph, you remember how to convert to slope-intercept form. If you need help, please go back and watch the video. Please raise your hand and I'll be more than happy to help you. Also, I just want to point out that number 4 and 6, you might get an interesting answer. Those are not going to have one solution, so I want you to see if you can figure out what type of solution those have, because they're not going to be intersecting lines. So I'll just give you a heads up in advance as you're filling in the gaps of those notes.